The launch is actually only the start of the important activities of Metop-C. You have a 16-hour launch countdown performed by Arianespace, in which Eumetsat participates. It's literally in a control room with a go-no-go type of arrangement. The spacecraft is launched, and then about an hour and a bit later, it's delivered into its final orbit by the frigate upper stage and released. That will actually happen as the spacecraft comes south, just to the west of Australia, and it's visible from a number of stations provided by both the launch service provider, and also the LEOP service provider. There's a number of ground stations in Australia, in Kerguelen, which is in the South Indian Ocean, Troll in Antarctica, Santiago, Chile, Kourou in French Guiana, right where the rocket originated from, and also Svalbard, although a different ground station from ours, where the European Space Operations Centre are able to monitor the operations of the satellite and its autonomous deployment of these activities. They then have a 3-day period where they deploy some of the doors and the opening of orifices and things like that, using pyrotechnic devices, and they prepare the spacecraft for delivery to Eumetsat, which happens 72 hours after launch.
The LEOP comprises the operations of the satellite that happen after the satellite separates from the rocket in space, until the satellite has reached an operational orbit, an agreed orbit, actually, which is a more correct term, with the battery charging, the solar array deployed, the instruments antenna deployed, and the first orbit determination done and the maneuver done.
In that time, there are a number of critical activities, especially at the very beginning, where the spacecraft is released from the rocket, and it has to be able to look after itself. So it has to deploy the solar array and start providing power for itself. If it doesn't do that quite quickly, then the spacecraft will not survive.
One of the most exciting thing, personally, I think, of the LEOP, it is the very first time the team has a chance to work with the satellite in its manned environment, which is space. It is the very first time. The LEOP for Metop-C lasts only 3 days, but it takes years to prepare, and the satellite is left at an altitude of roughly 800 kilometers in a polar orbit, which is gonna become a sun-synchronous orbit. And this is important because this orbit facilitates the measurements.
Metop-A has now drifted slightly because it's getting quite old. Don't have the availability of the fuel, but we want to make sure we have full control over the orbit. So that's drifted around a bit like that. So actually we're doing a bit more like that. Metop-C will be inserted into the gap between the two of them. It'll actually be put into an orbit about 16 kilometers lower. So they're operating at about 817 kilometers. Metop-C will be introduced at about 801, 802 kilometers, which means that, relatively speaking, it'll drift round the orbit. The lower you are, the faster you go around the orbit. It means that we'll then have about 15 days where we have the ability to decide where we push Metop-C up into the right position. So it drifts a little bit. Then we have this constellation in orbit where the 3 spacecraft are approximately equally spaced. We call this the tri-star configuration, a bit like a Mercedes star. Once that's there, then we start controlling the orbit fully again, and the spacecraft stays in a fixed location. We're going to commission the spacecraft in that position, and then we will decide later whether we stay like that or whether we move into a different configuration in orbit. I think more likely we'll stay like that.
The first phase of the commissioning, which is called the SIOV, the spacecraft in orbit verification, it takes about 6 weeks, and it involves switching on all the instruments, checking that they're basically working. For the instruments with infrared detectors, we need to start performing what's called a decontamination, where the infrared detectors are heated up. This can last up to a week or 10 days, depending on the instrument. And then, as I say, the first phase is the performance check on the instrument itself. The second phase is to check that the products which we derive from the instruments are coming out of the system. And that takes, if the initial phase is about 6 weeks, the second phase takes about 3 months. There are about 11 instruments on board. I say about because some of them actually measure things and some of them don't measure things, but they transpond data. So we have tests, specific tests that need to be performed on all 11 instruments. They need to be switched on, they need to be configured, and then we have performance tests. So we test various modes of the instruments which are not used during normal operations. And so normally after about a month after the end of the first phase, a month into the second phase, we have an internal review, and then we decide whether the data is ready, if you like, to be sent out to the early users. And this is extremely important. The users are extremely interested in that and in finding out how the satellite performs.